Let's talk about the general binomial expansion. So let's say we have 1 plus x to the power of n. 1 plus x to the power of n. Now this is, according to the formula for n is a natural number, we have 1 plus x to the power of n is equal to 1 plus and 1x plus 2x squared plus etc. plus n r 4x to the power of r plus etc. in which n r being equal to n times n minus 1 times n minus 2 times etc. times n minus r plus 1. Right, so these r over r factorial. So that's the idea of n over r. This is also equal to NCR, which is how you usually use in your calculator. Let's just say we have n is equal to 0. So 1 plus x to the power of 0 would be equal to 1, right? So in this case, since n is 0, so n does not go to n over 1 because this will be equal to 0 and all of these will be equal to 0. So this is equal to 1. So that's satisfied. If n is equal to, let's take a bigger number. Let's take n equal to 3. So we have here 1 plus x to the power of 3. Now this is so this is n over 1. So that's 1 plus 3 1 x plus 3 2 x plus this is 3 2 plus square plus 3 3 x cube. Now this is equal to 1 plus 3 1. So this is 3. This is n. So 3 times 3 minus. So let's say 3 minus 1 is 2. But 1 is r. So 3 minus 1 r. So that 3 minus 1 plus 1 would get a 3. So in this case, we only go to n. We cannot go to n minus 1 because n minus 1 is 2, but n minus r plus 1 is already 3, which is bigger than 2. So we only stop at 3. So here we have 3x over 1 factorial plus 3 times, 3 minus 1 is 2. 3 minus r is 3 minus 2 plus 1. So this is 2. And this is also 2. We don't get 2 here because this is 1 smaller than 2. So you don't get 2. 3 times 2 over 2 factorial x squared plus this is equal to x cubed. This is equal to 1. So here we have this is being equal to 1 plus 3x plus 3x squared plus x cubed, which is correct. So that is the general binomial expansion for n as a natural number. So what if n is a real number? So what if n is a real number? Now we have known that if it was n over r, that'd be equal to n times n minus 1, n minus 2 times n minus r plus 1 over r factorial. So if it was to write it in this form, we'll have 1 plus x to the power of n being equal to 1 plus n over 1 times x plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1 times n minus 2 over 3 factorial times x cubed, etc. So because n is not a natural number, we know that this value doesn't get to 0 at any point. So if n was a natural number, these get to 0 because among these there will be a natural number that being equal to 0 and making this product equal to 0. So if n is a real number, it is not necessary that this will become to 0. So this this expansion is infinite. So the expansion will be infinite. So that is one of the property if n was a real number. And another way for this to work is that n must be smaller than, the modulus of n must be smaller than 1. Because if n is got much bigger than 1, then these will just simply increasing through time. And this is to prove this is above the scope of A level, but the point is that the modulus n must be smaller than 1. So that is another properties of this if n was a real number. Let's see an example. So let's say they want us to find the expansion of root 1 plus x. And in this case, we have 1 plus x. This is equal to 1 plus x to the power of 1 over 2. And the modulus of 1 over 2 is smaller than 1. So now we know that this works. And this is to expand to the x term. So let's say we have 1 plus. Now for the x term, we have the formula is that it is equal to 1 plus n over 1 factorial plus n minus n times n minus 1 over 2 factorial x squared is x. So this is plus 2 1/2 over 1, which is equal to 1/2 times x. So if we were to put it to x squared, this will be 2 1/2 times 1/2 minus 1 over 2 x squared. And this is the cube term, which is continuing this trend and following the formula. Usually they won't ask you to more than cube term. And so that is the basic idea of a general binomial expansion. And usually there are other advanced forms, such as, let's say we have an equation in the form of 1 over the roots of 3x minus 2. This is equal to 3x minus 2 to the power of minus 1 over 2. So the modulus of 1 over 2 is smaller than 1. So we know that this is valid. And this is, some might be finding this quite weird. But here the way that you can solve it, you have to put it in the form of 1 plus x to the power of n. To do that is not difficult. So here we have 3x minus 2. And if we want 1 plus x, we must try to get this 2 to be positive. So we put a negative sign in front of it. So we have 2 minus 3x to the power of 1 minus 2. So this is the same thing. And this is also equal to 3. Minus 2 times 1 minus 3 over 2x to the power of minus 1 over 2 to the power of minus 1 over 2. So this is another way in which you can get it, and in this case minus 3 over 2x is considered as x in this equation. And here, by putting out a constant value, you actually achieve that, and if with this equation you can actually use the general binomial expansion. So that is mostly what you need to know about the general binomial expansion. So over the course of the video, I've said that the requirement for when n is a real number is that it will be an infinite expansion. And I also say that the modulus of n must be smaller than 1. So this is not actually true. This is wrong. And the fact is that it must be that x, the modulus of x is smaller than 1, not n. So the modulus of x must be smaller than 1. So this is the condition for the general binomial expansion to work when n is a real number. So the modulus of x is smaller than 1, not the modulus of n.